So this is a summary of the theory that I've been working on. It is quite complicated in terms of mathematics, but I have made a simpler version, hopefully, that you and the average listener can understand just fine. Okay, ready?
Okay, let's dive right into this.
All right, here we go. Title: A New Way to Understand the Universe. Introduction. Imagine the universe as a giant puzzle. For a long time, scientists have been trying to put together the pieces of this puzzle, but two big pieces, quantum mechanics and general relativity, just don't seem to fit together. We found a way to take these pieces and make them fit by looking at the universe like it's made up of tiny building blocks. The universe is building blocks. Think of the universe like a Lego set. I wonder if that might have inspired my thinking. Each Lego brick represents a tiny piece of space. These bricks are so tiny that we can't see them. We think everything in the universe is made up of them. This is much smaller than an atom, much smaller than an electron. This is like tiny, 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 tiny. Okay?
You mean quarks?
Smaller than quarks.
I forget what they're called.
What?
What's smaller than a quark?
No.
I know they have a name.
No. So quarks, as far as we know, quarks are fundamentals. So quarks and electrons, as far as we know, they don't have parts.
Oh.
So they're point particles. Or as near to it as they can get. So, this tiny, tiny, tiny scale, okay? In the world of the tiny, like atoms and particles, things don't work as we expect. This is called quantum mechanics.
Mm-hmm.
It's like a dice roll.
Yes.
Okay? Instead of following set rules, everything is based on chance. It's like rolling a dice. We can't predict the exact outcome, but we can guess the chance of rolling a 6. Right?
Yes.
Okay. General relativity. The bendy sheet. Have you seen these videos of...
I have.
It's so cool. It's, if you haven't seen them, audience, go to Google, or go to YouTube, I should say, and search for general relativity sheet. And you'll find these amazing videos of them rolling these balls around on these, like, nylon sheets, where you can see a simulation, a real-life simulation of the space-time being deformed by mass. So, this is planets, stars, really big stuff. Imagine placing a ball on a stretchy sheet. The sheet will bend around the ball. In the same way, heavy things like stars and planets bend space around them. That bending is what we call gravity. Right? Making these pieces fit. Our new idea is that these Lego bricks of space can act like dice, playing the game of chance, but they can also bend like the stretchy sheet. Oh, what a shock, it's both.
What a shock.
What a shock, it's both. It's a yes and. What a shock.
What a shock.
People have been fighting over whether it was one or the other for decades, and what a shock, it was both. So, they can behave in the way of both quantum mechanics and general relativity at the same time. Now, the role of computers. This is pretty complex. So we used the ChatGPT supercomputer, which now anyone has access to. Anyone can access this for free. And we are working on the mathematical concepts that describe it, and specifically what deviations, not the same, as the same way that Newton was improved by Einstein, this could improve the accuracy of Einstein's equations.
Okay, cool. Very interesting, my dear.
And what we think we've done, this is the conclusion, okay?
Mm-hmm.
What we think we've done is we've found a new way to understand how the universe works. By thinking of it like a giant Lego set where each brick can both play dice and bend like a sheet. Each of the pieces can bend. Of course they can. It has to be true. Because the bending of space and time doesn't affect what's inside of it. Well, gravity affects it. Well, it's complicated. But it's both, is the point. It's both quantum mechanics and general relativity, and you just have to put them together to have the theory of everything. And then, what do you think will happen once people can sit down in their living room, just as I just did, sit down in their living room and come up with a new way of looking at the fundamental laws of physics? What do you think will happen to science? What do you think will happen to industry? What do you think will happen to the economy when anyone can do this?
I don't know. Let's find out.
I don't know. Let's find out. A perfect place to end. Well, thank you very much for listening to this very short episode, but I hope it was enlightening to you.